So the problem here is a pure exchange economy is to complement utility consumers. So we do this exactly the same way as we normally do it, just the algebra maybe, no, algebra is not harder, but maybe a bit trickier to realize what's going on. So we have 20 units of x and 10 units of y in total, so it's not a square, so it's a rectangle, which makes this question 10 times harder. So remember the shape of these things. So on this side it looks like this. On the other side it looks like this, not also L, it's with respect to the other person. So if it's hard for you to understand it, just turn the paper around and then you will see that these are L-shaped stuff as well. So we do it this the exact same way as before. We fix one and maximize the other one, right? So we fix one at, say, U bar. I don't know where along this curve it is, but I don't care. So I fix this and I maximize the other person. So the other person moves this way. So the highest I can go is like this, so that they still have intersection, right? So if I move further, there's no way that they can intersect. So when I move to this is the highest possible one. Then the common allocation is a set. Normally we had this, where the common intersection is 1 point. Now we have common allocation is a set, so we need a set as our Pareto set. So our Pareto set mathematically can be given by this is XA in between YA and YA plus 10. So on the exam, if you think this, you don't know where this comes from, it's okay. You can just draw a diagram and label everything very clearly. So you need to know it's 10 here, it's 10 here, and 0 and 20. So on the exam, you know that if we change this, so think like this, so change it to U bar prime, then we have a similar situation where these are all the ones. So you can probably see directly that this parallelogram, any point inside is Pareto efficient. So this is the Pareto set. So if you draw a diagram like this on the exam with clear labels, which one is A, which one is XA, which one is YB, and so on, then it's okay. You don't really need this. So, and yes, the competitive equilibrium. So competitive equilibrium starts here, and then we need to find somehow. No, this diagram is too messy. I'll draw a new one. So doing it exact same thing. There's one of them like this, the other one like this. And suppose our endowment is here, then given any kind of price, intuitively, it looks like this. Remember, this is these L-shaped, and the other ones are these L-shaped. So one point is always here, the other point is always here. So no matter how you move the prices, so think about moving price to another slope, then still one of them look like this, the other one look like this. So these 2 points will always be 1 point along this line, the other point along this line. So there's no way of getting them at the same place. So that's why there's no equilibrium. So that you actually cannot use diagram, because there's no way of showing there's no natural. I mean, not. I'm sorry. So no competitive equilibrium. So in that case, you actually need to find the numerical demand. So that you need a bit of mathematics. So some of you are thinking about p equal to 0, p equal to infinity, but the problem is when p is 0 or infinity, everyone wants none of this. This doesn't work as well, right? So if it's 0, then everyone wants infinite number of them. If it's infinity, then no one wants anything. So those normally will not be competitive equilibrium as well. So that's why this thing has no equilibrium. So the detailed mathematics again is in the solution which I posted already.